All right, we're back recording. If you guys enjoy that double slit, then I can fit in Schrodinger's cat by the class. We'll see. But let's do some color theory. So if you shine some light, actually, here, I've got the actual lamp version of this. Because if you look down on your phone screen, right, your phone screen, let's say it has all the colors, right? But really, if you were an ant crawling around on your phone screen, you would only see three color lights light up. What are those three colors? That's right, RGB, red, green, blue. It's called the red, green, blue standard. And so here's three color. And what if you shine all three lights at the same time? What color do you get? White. Do you guys know the scientist that first figured that out? That was Isaac Newton. Isaac Newton. Right. Wait, how do you make yellow? Red and green, right here. Right, red and green make yellow. Right. Or I think probably most of you guys see this. I mean, some people are colorblind, so you're colorblind. Right. Oh, speaking of colorblindness, you really only have three color detection cones in your eyes, and one for red, one for blue, one for green, and then your mind puts them all together. I think dogs don't have the red one. I think so. If you throw a red ball in the grass, they can't see the red ball. All right. There you go. All right. So that's called additive color mixing. That works with lights. But what about paints or paint pigments? Because you mix all the paints together. Or how about like a dark muddy color? Or how about this? What are the three colors in your color printer?
Yellow, magenta, teal.
That's it. Yeah. You got them. These three right here. Got them. Yeah. And if you ran out of black ink, you could get black from the colors. You just mix them all in the but because with subtractive color mixing, the more colors you add, it subtracts out whatever colors of light lane on it and reflects everything else. Okay. So there you go. All right, so there's two kinds of color mixing. Now we're gonna make a Newton's wheel and a Benham wheel. So actually got a model here so I can show you guys. Here, show you guys exactly what we're creating. Okay. So there's some geometry involved in this too, but now this doesn't work very well on camera because like frame rates and whatnot, but this works really well in real life. This is called a Newton's wheel, right? So Isaac Newton realized that if you take all the colors and you spin it, it's going to turn to white. Can this work? Oh, actually, that all right on camera. I don't know if it'll work on the recording, so I'm watching it in the projection. Yeah, it's okay. But it works really well in real life. It looks like it goes to white, right? And then on the other side is now this is clearly just black and white, right? Black and white stripes. Now those stripes are different lengths, and that's interesting. Okay. But again, there's no colors here. Now this one works for some students, but not everybody. It works for me. Now I can see this, not everybody can. Again, it works better in real life than through a video camera. But when you get the spinning, you might see different bands of colors. Like to me, here I'll tell you what I see. I see the inner bands look kind of red, and then gold, and then kind of green, and then kind of like blue violet. Right. Also, whether I do this clockwise or counterclockwise makes a difference. I have no idea why that would make a difference, but right, the colors are different. So anyway, that's what we're putting together. We'll put this together right here. Right, so you guys see the geometry of this. Now, part of the detail. Do you guys see these spacers here? Like these like spring little spacers. Right? So like if they didn't have those, if I just glue these two discs side by side or back to back like this, right, and then I pull the string, it always flips this way and wants to rotate about this axis right here, which would be no good. Right? So that's what the spacers are for. Right? You guys see that? If I can get more spacing that way than between these two holes where the string's going through, right, then it'll spin around about the correct axis. Okay. Right. So a little geometry going on right there. All right. So let's put this together. Hey, you guys got some scissors? Okay. Now there should be maybe an extra margin on the right side. See how I got some margin here? Okay, let's get this green background. I think it makes more sense. Okay. You guys see an extra margin on the right side? Go ahead and cut that out because you're going to use this for the spacers. You probably want maybe 4 rectangles out of this that I can use for the spacers. Right. Get my model back up here. You guys see how each one of these springy looking spacers could have started as a rectangle strip, right? Okay. For extra context, if you're just watching a video at home, this is out of cardstock. So if you want to make a really good one, get some cardstock paper. It's really nice, thick card. Of course, you're in class. That's pretty obvious. Okay. All right, then cut out these circles. Let me check in on you guys. All right, yeah. Some of you guys got the circle. Some of you guys are up to where I am. Some of you guys are getting pretty close. But all right. Ooh. All right. So you guys remember this extra rectangle margin? I'm gonna get 4 rectangles out of this, right, so that I can make these springy spacers. Right? Now, I do want these to be the same, so that there will be radial symmetry, right? Like I don't. Is it true I want the center mass of this whole project to be also at the geometric center, so it'll spin around the geometric center really nice? Okay. So you guys got rulers nearby. Might be a good idea to whip off a couple of lines to make sure that you're cutting this exactly in half along each axial direction. Or maybe I should fold this in half. That would definitely give me a half line, wouldn't it? Okay. Or you could measure. Okay. Point. Right. So I think that right there will give me 4 equal pieces, right? Equal mass pieces, so that the center mass of this project also aligns at the radial center, the geometric center of the whole project. So these are going to be my spacers. Four spacers here. All right, you guys getting some spacers? Got those? What else? Ooh, well, I know I have to cut a couple or punch a couple of holes here. Punch a couple of holes, right? On both sides. So try that. Yeah, maybe I should measure it first. That's always a good idea, right? Because you can only punch a hole once. Right? Now, if you totally mess up punching a hole, you could take some extra cardstock, maybe some of the scrap, and go through and like patch it up with the glue bottle. You guys got glue within reach too, right? You guys got all this going on. Right? But I measure. What do I want to do? Maybe I'll do from the center, maybe a half centimeter one way and a half centimeter another way. So that the distance from dot to dot is 1 centimeter. Okay, punch hole there. Right, I think that should work pretty good. Okay. Like if they're too close together, then as you're pulling on it, it might be easy to for the string to just like cut straight through the center. So you don't want to be too close. Okay. But if you get them too far away, then this might not spin along the correct axis. Okay. So maybe there's like an optimal place to place this. I think that should work pretty good. And same. I did 1 centimeter separation distance. So from the center, so if you measure it from the center, I went a half centimeter one way and half centimeter the other way to get a 1 centimeter separation distance. Here, I'll do the same thing on the Newton's wheel over here. Here's my central dot, bam, right there. There's like the center, right? The geometric center is center mass. Right? And then go half centimeter one way, half centimeter the other way. Here's my 2 dots. And then very carefully, couple holes right there. About like that. Right. So I want to see here, put one of these upside down and get these spacers out. Well, here, I'll pull these into little springs first. Right, so let's go back and forth, back and forth, back and forth. Right, to make these look like springs. Right. Actually, maybe here's a better way to do it. Maybe I'll fold half, half, and half. Yeah, and then now that I got the crease marks, now I can go back and forth accordion style. Back and forth and back and forth and back and forth. Right. So there's 1 spring spacer. Right, 1 down, 3 to go. Right, fold in half, half, half. Right, now I have 8s. Okay, pull that apart, and now accordionize this back, forth, back, forth, back, forth. Boing, 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 boing. There's 2 spacers. A third one, half, half, half. Pull that. So back and forth, back and forth, back and forth. Boing, 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 boing. 3 accordion spacers, 3 spring spacers. half, half, half. Back and forth, back and forth, back and forth. Oy, 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 oy. Four spring spacers. Four spring spacers. That's how you guys are doing. You guys are caught up to that step. Ooh, yeah, looking pretty good, pretty good. All right. I think you guys are doing pretty good on this. Pretty good.
Caffeine isn't poison, it's just, let's just think about it this way. Old White Monster is like the Jesus cried. I'm sorry. And they didn't drink out. That's how I would describe the flavor. It's the best thing on planet.
All right. So yeah, flip one of these upside down and need four of these spacers. Now I need them to be exactly opposite ends of a diameter. So if I hold my ruler across, I know if you go like right here, bam, bam. So I can put a couple of glue jabs right there. Right. Then turn those. Ooh, you guys have protractors too. So let me mark out exactly 90 degrees. Then just to keep it symmetrical all the way around. Bam, there's 90 degrees there. And flip it the other way. Go 90 degrees here. Bam, it's pretty good. I double check with my ruler, make sure these line up across the diameter. Oh yeah, look at theirs, right across the center. Right. So I got four marks to place dabs of glue. Get these springs going. Alright, so if you press and hold those for 20, 30 seconds. All right, that should glue in place right there. Okay. And then at the top of each one of these spring spacers, put another dab of glue. Okay, and then so I'll put the other wheel on top of this, but guys, when you're fixing the other wheel, make sure that the holes in the center line. You guys remember punching those holes near the center? Make sure that the holes are aligned so that you can see all the way through. In fact, what might have been a good idea is maybe punch the holes after the fact, so for sure they're aligned. But I think I can make this work. Okay. So get this on here, and if they aren't aligned exactly to start with, then I can just shift this around a little bit until they are, because the glue's still wet for a little bit. Make sure I can get a hole going all the way through. How close is that? Oops. Rotate it this way a little bit. Try that again. Okay, right there, bam. Right there, bam. Okay, yeah. All right, that's going through now. All right, so press this down. Make that glue dry right there. Yep. These holes are aligned. Yep. All good. Got to press this down and wait for that to dry. On the right track here. All right, string time. All right, so I did cut some string for you guys before class started. This is actually hold this next to a meter stick off camera. Yeah, this is about 1 meter long. Mine's a few centimeters over. All right, so it should be about a meter. All right, so if you want a measurement value. All right, so I need to push this through these holes here. Maybe like make a little knot. Maybe that'll be easier to work with, I think. All right, take this pen and push this through. Pull it through the other side. Boink. Now the string going through. right, and then push it through back the other way. Okay, so we're gonna make one giant loop, right? One giant loop, right? So pull it through like that, right? Okay. Right, so guys, this is all one string. It's all one string. You guys see how it loops through? It's all just one string. See it loops through like that? It loops through. Okay. Okay. Now, these two ends right here I can tie together. So here's the two ends. So it's only ever one string we're working with. It's about 1 meter long. I just got to tie these ends together at point like that. That's it. Okay. And then pull this out. Okay. What's out here? All right. Oh, and then to wind it up, all you have to do is this type motion. Right. Just go around like this. It'll wind it up. All right. And then when you pull it, there's the Benham's wheel side right there. Benham's wheel. Yeah, it works really well in real life. Well, for most, I shouldn't say for everybody. Some people can see the Benham's wheel, some don't. I do. Doesn't work for everybody. But the Newt's wheel side, yeah, I think that should work for everybody. You should see all the colors combined to make white. Right? Again, on camera, it works so great because there's a certain camera frame rate. But in real life, the Newt's wheel works really well. Okay. All right, so there you go. There's the Benham's wheel and the Newt's wheel right there. All right, I walk around and check on you guys. All right. Yeah, it looks like you guys are doing a real good job on this project. Yeah, we have a solid 20 minutes about it here, which is more time than I thought, which is really good because, right. I showed you guys the double slit experiment. For the rest of the class, I'm just going to roll the rest of these so you guys get to at least be familiar with Schrodinger's cat, Heisenberg uncertainty, quantum entanglement. Okay. Yeah, the full version of this with my other classes, I'll take like several days, maybe like a full week to teach us. So like there's some build up to start explaining this, but at least you guys get these ideas. So yeah, if any of these ideas really intrigue you and you want to look up more about it, then well, you got all summer.